Hello students, today we will see very simple yet very important concept which is isoelectronic species from chapter number 4, structure of atom. So this is simple concept but it come for 2 to 3 marks in your exam. So the definition is already given here, which is atoms or ions with similar number of electrons. So isoelectronic means iso means same and electronic, that is number of electrons. So you have to find atoms or ions with similar number of electrons, and we can call them isoelectronic species. Now let's get into the examples of it. For example, I write N minus 3, O minus 2, F minus 1, Ne, and Na plus. Now here you can see N minus 3, O minus 2, F minus 1, Na plus are ions. Why they are ions? Because all these are charged species. They are having charge above them. That is here in case of nitrogen, minus 3 is the charge. In case of oxygen, minus 2 is the charge. F minus 1 is the charge. Sodium plus 1 is the charge. But in case of neon, Ne, neon is not ion, it is atom. Why it is not ion? Because it is chargeless, no any charge above here, so zero charge. So these are ion, these three are ions, this is also ion, and this is atom. So according to definition, atoms or ions with similar number of electrons are isoelectronic species. Now we will calculate. So first of all, you should understand how many number of electrons are present in every species. Now how to find that? If I represent this carbon species, that is 6 carbon 12, 6 is the atomic number, and atomic number is same as number of electrons present in them, which means 6 is the atomic number of carbon and 6 are the number of electrons present in the carbon species, which means you have to keep in mind all the atomic numbers of the species. If you know the atomic numbers, you can say the number of electrons present in them. Similarly, nitrogen, so the atomic number of nitrogen is 7. You can say atomic number of nitrogen, or you can say number of electrons in nitrogen are 7. Now what to do about this minus 3? We will add this 3. Why adding this 3? There are minus 3. Why minus 3? Because minus sign represents the charge of electron. One electron represents minus 1 charge. Okay. So if we are adding electrons, we have to add plus 3 and not minus 3. Okay. So that is 10. What about oxygen? Atomic number of oxygen or number of electrons are 8. Plus 2 we will get 10. What about fluorine? Fluorine atomic number is 9 plus 1, that is 10. What about neon? Atomic number is 10. No any charge, so no need to subtract or add anything. Atomic number or number of electrons 10. And sodium atomic number is 11. If you have plus 1 charge, you will remove 1, that is minus 1. That is you will get 10. Why minus 1? Because you are removing 1 electron, which means you are getting plus charge. And removing 1 electron means you are removing 1 negative charge. So you are getting minus 1, removing 1 negative charge, that is 10. So here all you can see, all the species have number of electrons are 10. Okay, so all these species N minus 3, O minus 2, F minus 1, Ne and Na plus 1 are called as isoelectronic. Why isoelectronic? Because all are having same number of electrons. Now let's see another example. Now, if I write CO, Cn minus 1 and N2, how to calculate? Similar. Now here, carbon, oxygen. Carbon is 6, oxygen is 8. You will get 14. Okay. Then again, carbon is 6, nitrogen is 7. And what about minus 1? You will add 1. Isn't it? So 6 plus 7 plus 1, that is again 14. What about N2? One nitrogen is 7, other nitrogen is also 7. You will get 14. So CO, Cn minus 1 and N2 are also isoelectronic species. Next, N2O and CO2. Now, can you comment the answers of N2O and CO2 and tell me whether these two are isoelectronic species? Let me know in the comments below. Thank you.